Thakur Vidya Mandir High School and Junior College welcomes all the 12th standard computer science students. We are going to learn a new concept from Unit 3, Introduction to x86 family, that is the programming model of 32-bit microprocessor. This is the diagram of 32-bit microprocessor. You can see the diagram of 32-bit microprocessor is almost similar to the 16-bit programming model that we have learned in the previous class. So let us elaborate about each and every block in detail. The 8088 and 8086 defines the basic programming model for the entire x86 family of advanced microprocessor. As we know, when the advanced microprocessor came into role, 8086 was the first 16-bit advanced processor developed by Intel. So when the programming model of 8086 was designed, this became the base model for all the advanced registers that was microprocessor that was generated later. So the advanced microprocessor are 80286, 80386, 80486 and 80586. The newer members of x86 family have greater computing power because they are faster. So the instructions were more advanced as well as their speed was more. So they have greater computing power because they are faster. They use 32-bit registers instead of 16-bit register, and they have advanced addressing techniques. So there are different addressing modes via which the instructions can be easily accessed. The programming model for 32-bit version of x86 family used in 32-bit microprocessor family, that is 80386 and 80486. So the 32-bit version was only used in the two base processor, that was 386 and 80486. This 80386 and 80486 are further classified into two versions. They are as 80386 SX model and 80486 DX model. So these were the two different models that was generated by two different versions of 80386 and 80486. Now let's learn the programming model of 32-bit family in detail. Into three different groups. They have the general purpose register, the segment register, instruction pointer and flag register. Now let us learn about each and every grouping. The general purpose register are AL, AH, that is accumulator, accumulator lower order, accumulator higher order. This is the 16-bit register, and here I am extending it to form 32-bit. So here E stands for extender. Similarly, we have before that, you can see how the bifurcation has been done: 0 to 7 for 8-bit, 8 to 15 for 16-bit and 16 to 31 for 32-bit. Similarly, we have BHVL, together we call it as EBX, CHCL, together we call it as ECX, DHDL, and we have EDX. So as we know that AL, BL, CL and DL, all these are the lower order register, whereas AH, BH, CH and DH all are the higher order registers. They together can perform 16-bit operation, but when I am extending it to 32-bit, that time we call the registers as EAX, EBX, ECX and EDX. So let me say in short about the function of all the registers. A register is the accumulator while performing arithmetic and logical operation. One of the numbers should be stored in accumulator. After the operation, the final result is stored in accumulator. Now BX. BX register is similar to the memory pointer that we have learned in the register group of 8085, which is the HL register pair. CX. CX stands for the count register. The count register is similar to our counter, which is used for our string operations. That is, whenever we want to access a group of numbers at that time, we always set the counter using the CX register. Lastly, we have the DX register. So we know the DX register plays a very important role. That is, we know the capacity of the 32-bit microprocessor is just 32-bit. So when I am multiplying 32 into 32, the answer will be more than that, more than 32-bit. So the extra number, whatever we are getting, we will be storing it in the DX register. We have SI, which is 16-bit. When I'm extending, it becomes a ESI. DI, which is 16-bit. EDI, 32-bit. BP, EBP, and similar way SP, ESP. So here the general purpose registers, apart from programming, they we also have the index register as well as the base pointer, that is the pointer registers. So here the index register and the pointer registers all are of 32-bit. Each and every index register and the base pointer and stack pointer has its own functions. So let us elaborate in short what are the functions of the registers. Firstly, we have the stack pointer. It is a 16-bit register. It points to the program stack in the stack segment that we will learn in the segment register. Base pointer. It is also 16-bit register. It points to data in the stack segment. Base pointer register is usually used for based index or register indirect addressing mode. So during this type of addressing mode, that is whenever we are learning instructions related to the addressing mode, at that time the base pointer plays an important role. SI, source index. It is a 32-bit register. Okay, and we know this SI and DI, that is the destination register, plays a very important role during string manipulation instruction. That is whenever we want to transfer a 10 or 20 data from one part to the other part, then the first part becomes the source index where the 10 or 20 data will be stored, and wherever it is transferred, that becomes the destination register. So these are all about our 32-bit general purpose register. So we have accumulator, base index, count register, data register, source index, destination index, base pointer, and stack. It is similar to the 16-bit general purpose register. The first group contains 8 general purpose register called EAX, EBX, ECX, EDX, ESI, EDI, ESP, and EBP registers. Here E stands for extender. So here where E tells us that these registers have extended length. Each register can be addressed in 8, 16 or 32-bit models. These registers are used to store data during computation. So whenever there is a computation operation going to take place, we are going to store the register. That is simply our arithmetic and logical operation. ESI and EDI registers are used during string operation. EBP, ESP are also 16-bit registers which are called as the pointer registers. Pointer registers are used to point locations within the segment. So whenever we are going to learn the segment registers, the pointer registers plays a very important role. Next comes the segment registers. We have CS, SS, DS, ES, code segment, stack segment, and we have here FS and GS together, which are called as the data segments. Now let me say firstly the speciality of segment registers. We know the segment registers is being done, segmentation of memory especially is being done with the help of the segment registers. Segment registers plays a very important role while performing any operation with the external memory. Segment registers, each and every segment has its own specification. The most important segments are the code and the data segments, because we know code segment will be containing all the instructions that we require to execute the program, and data segment, that is DS, especially will be having all the data that we require for the operation. So the segment registers here in 32-bit family are of 16-bit, and here we have code segment, stack segment, and 4 data segments. So the 4 data segments are DS, ES, FS, and GS. In 16-bit family, we were having 2 data segments, but here in 32-bit family we have 4 data segments. The segment registers plays a very important role with external memory. All data transfer operation and computation takes place with the help of the segment registers. The second group of registers is called as the segment register. This group consists of core segment, stack segment and 4 data segment registers. The data segment registers are DS, ES, FS and GS. These are 16-bit registers. These registers manage operations with external memory. Address computation and data movements are performed. Next comes the third group, which is your IP, instruction pointer, and we have the flag register. So here the instruction pointer and flag register both are of 32-bit. So EIP, here E stands for extended, and E flags. And E flags we can see here, it is further bifurcated into two parts as flag L, which is the first 8-bit. The next 16-bit will be flag H, and totally as a 32-bit it forms the E flags. Okay, so here the flag register and the instruction pointer is of 32-bit pointer. That the programming model of 32-bit family is differentiated. That is, it is divided into 3 register group: general purpose register, segment register, and thirdly comes the instruction register pointer and the flag register. The general purpose register are of 32-bit, where E stands for extended. Here, the registers plays a very important role for data movements as well as computations. Without the registers, we won't be able to do any program. Apart from our general purpose register like EAX, EBX, ECX, EDX, we have index registers and we have pointer registers, which forms a part of our general purpose register. We have next be the segment registers. We have 4 segments, stack segment and 4 data segments. And lastly, we have the instruction pointer and the flag register. That's all about the programming model of 32-bit family. The flag register of 32-bit family. Firstly, starting with the LSB. We know 32-bit family means it is going to be our 32-bit flag register starting with our carry flag. So the D0 bit is occupied by the carry flag. As we know, during arithmetic operation, if there is a carry from the D7th bit, the flag will set or else reset. D1 bit is empty. D2 bit is occupied by the parity flag, which says about the number of ones. If the ones are odd, it will be reset. If it is even, it will be set. Again, D3 bit is empty. D4 bit is occupied by the auxiliary carry flag. Whenever there is a carry from D3 to the D4 operation bit, at that time the flag will set. D5 bit again empty. D6 bit is occupied by the 0 flag. So as we know, 0 flag after the arithmetic operation, if the 0 is set in the answer, the flag will set. That is, if the answer contains 0, the flag will set. If the answer doesn't contain 0, it will be reset. Next comes the sign flag. So sign flag, as we know, after the arithmetic and logical operation, if the answer is negative, the flag is going to set. If it is positive, the flag will be reset. D7th bit. This 7-bit already we have learnt in 8085. Then comes our trap flag. So already I have discussed what is the function of the trap flag. So we know that is whenever the microprocessor is executing a program, it does 2 type of operation. That is, one, it will execute all the program. The second is, after executing each and every instruction, it enters a subroutine, that is single step mode. After executing each and every instruction, it enters a single step mode where a small subroutine will be generated to check the error checking in the program. That is, if any error is there in the instruction or not. Interrupt flag, whenever there is an interrupt, the flag will set or else it will be reset. D9th bit is occupied by the interrupt flag. Then comes the direction flag. As we know, direction flag plays a very important role. That is, whenever we want to sort a data, that is the memory location, from higher to lower, the flag will be set. Higher to lower, it will be set. Lower to higher, it will be reset. D10th bit is occupied by the direction flag. Next comes the overflow flag. As we know, if I am doing 32 into 32-bit multiplication, at that time, what is going to happen? We get the answer more than 32-bit. So, the extra data, whatever we are going to get, will be stored in which register? DX register. As well as the flag will be set. Now, this flag, overflow flag, is for 16-bit operation. That is, whenever I am multiplying 16 into 16 or dividing 32 divided by 16, at that time, this flag will be set, overflow flag. Then comes the D12 and the D13th bit. The D12th and the D13th bit is occupied by the in-output privilege level. It is used in protected mode to generate 4 levels of security. Now, the microprocessor here will be working in different types of mode. One will be the protected mode and second will be the real mode. In real mode, till certain memory location it will be accessing, and in protected mode, till certain memory location it will be accessing, and it will be differing from processor to processor in output privilege level. The D14th bit is occupied by the nested flag. Nested flag indicates that one task has invoked via, that is in one task there is one more task nested. Similarly, just like our C++, we have the for loop. Loop within a loop is a nested loop, right? So whenever there is a program or a task event, inside the task if it is nested with some other tasks, at that time the flag will set or else it is going to be reset. Nested flag. Overflow flag, again the D15th bit. This overflow flag is applicable for the 32-bit processor. That is, when I am multiplying 32 into 32 or 64 divided by 32, at that time the flag will be set. Then we have the resume flag. It is used by the debug registers. It enables you to turn off certain exemptions like debugging code. While debugging, that is while checking up the errors in the program, at that time we will be using up the resume flag. Next comes the virtual mode flag. That is whenever the processor is going to work with the virtual memory. We already discussed about the virtual memory mode in the processor. We also have here one more mode, virtual memory mode. If whenever the processor is going to work with the virtual memory mode, the flag will be set. Okay. And last comes the alignment check flag, and from 19 to 31 it is reserved. It is reserved for the 62-bit processor. So it is reserved for the 64-bit processor. That's all about the flag register. Now, here we are not going to elaborate about the functions of each and every flag. The reason is we are only going to draw here. In your board exam, it will be only asked to draw the flag and label it. So you are only going to draw the flag and label it, and you are not going to explain the function of each and every flag. Okay, by this we complete the concept of 32-bit programming model as well as 32-bit flag register. So here 8085 microprocessor has 8-bit flag register from 0 to 7 with 5 active flags. This is how the bifurcation has been done. 8086 and 8088 microprocessor has 16-bit flag register 8 to 11, and the remaining bits from 12 to 15 was unused, that we have done in the last class. 8 to 11 we have the direction flag, trap flag, interrupt flag and overflow flag. 80286 was also 16-bit flag register, but 12 and 14 bits were added, that is in output privilege level and nested was added. 80386 microprocessor has 32-bit flag register with 15 to 17 bits. So 15 to 17 bits were added in the 80386 processor, where we have the resume flag, we have the virtual mode flag, and we have the overflow flag for 32 bit. And 80486 has 32-bit register with new 18th bit, that is the alignment check. And the remaining bits from 19 to 31 are reserved for the advanced processor. That's all about the flag register of 32-bit flag. Thank you.